I'm going to do them both ways. When we're given a problem and there is no acceleration, we want to find, there's only one thing we can do with no acceleration is find our distance. We don't know what the acceleration is. We don't know how fast. We can just find an average of how far we think it's gone. So it's an average distance, okay? This is this. Delta x equals v initial plus v final over 2 times t. This is not on your formula sheet. This is the only one that's not on your formula sheet. You take the average velocity over that period of time and you divide it by, or you multiply it by the amount of time. Do you get why we say average velocity? Isn't this an average? We take the initial and the final, we divide it by 2. We don't know. See, here's the thing. If we don't know the acceleration, we don't know if it's sped up, slowed down, sped up, slowed down. We don't know what it was doing, did we? So all we can do is say, we know at this point, over this period of time, it was going this fast to this fast. That's all we know. So we're going to average that out, and we're going to multiply it by the amount of time it took to get that, to over that speed, that we were at that speed, and that's going to give us about an average of how far we went. Make sense? Okay. No displacement. If we don't know the displacement, these are qualified by what you don't know. V final equals V initial plus AT. Now this one is on your sheet. Your sheet lists it as V equals V naught plus AT. So that is V final. V is V final. V naught is V initial. Naught means at the beginning, not as in 0. Okay? This is the one that's actually on your formula sheet that you should be able to recognize. Okay? Now, change in, the next equation is delta x, the change in position, that would be delta x, wouldn't it? Equals V initial t plus 1/2 AT squared. Now that is not how your formula sheet writes it. Your formula sheet writes it this way. X final equals where you started x initial plus V initial t plus 1/2 AT squared. This is what's actually on your formula sheet. Okay? Oops. That's what's on your formula sheet. Do you understand where the delta x comes from that I use? Delta x would be the changed position. This would be x final minus x initial, wouldn't it? What would happen if I took this and moved it over to the side? It'd be minus, wouldn't it? So this minus this is what gives me this over here. So please just understand that this and this is actually on your formula sheet. This is the same thing as that. Okay? We can find the change in position if we know everything. Do y'all notice what we don't know is the final velocity in that equation? That equation does not require the final velocity, does it? There is no V in that, V final in that. All right, so what's the next one? No initial velocity. That's fine. We could do delta x. Ooh, excuse me. We could do delta x equals V final t minus 1/2 AT squared. Do you see why this gives you, why if we use the final velocity, this one's not on your formula sheet, but does it make sense to you? If we know how fast we were at the end, and we subtract away how much we accelerated, wouldn't that give us how fast we were going in the beginning? That would give us our position. So since it was V final t, we did minus 1/2 AT squared. Now, if we don't have time, there's only one equation of all the kinematics equations, what we call the big five, that does not include time. That is the third equation on your sheet. It says V final squared equals V initial squared plus 1/2 2, excuse me. Just had a little brain burp there, plus 2a delta x. Now, this is not what your formula sheet reads. Your formula sheet reads this way. V squared equals V naught squared plus 2a times x minus x naught. Do y'all see that's the same thing? This is x final minus x initial, isn't it? Isn't that delta x? V final just writes, they just write anything final is just the variable, and V initial is V naught. Okay? This, and this are the three equations on your formula sheet that you will be given on the test. Okay, when you take the exam. These three. So the cool thing is you don't have to memorize those. You get this with every test you take in here. As a matter of fact, I suggest you have this out. I gave you a copy of this, didn't I? In the very first day? I thought I gave you one that was white. In your initial stuff, I thought I gave you a formula sheet. A set of formula sheets. You got a lot of stuff that day, I know. If I didn't, I need to know because I need to make you one. We didn't get one. I'll get you some next time. I'll get you some folders. I'm sorry. So that you have a set that you can use at home. These are always here, so when you take tests, you know, and I color code them so you know which one. I've got 3 different APs so you can figure out which one's yours. All right. Questions so far? We still good? All right, so let's do these and let's figure out how we use these. Guys, kinematics, these formulas, these big 5 formulas, only work if we have a constant acceleration. These don't work if we're going fast, if we're changing our acceleration. They only work with constant acceleration or uniform acceleration. Uniform acceleration is the big deal. If the acceleration is not uniform, we cannot use kinematics. Okay? Now you know why we suddenly will change to doing dynamics. Guess what dynamics means? The acceleration is changing. So next unit, we'll look at these from the standpoint of what happens when we aren't accelerating uniformly. So for now, we've got easy ones, okay? So how do we solve a kinematics equation? How do we solve a problem? You want to list your knowns. Okay, list your known quantities and your unknown quantities, right? Hopefully there's only one unknown quantity. Then you're going to figure out which kinematics equation am I going to use. Then you're going to plug in your values and solve for your unknown. All right. We got time for one example here, or two, and then we're going to, we obviously are not going to get through all of this today, but we did get through 1-1. So you do have your 1-1 practice problems to do. Just not 1-2, okay? Because we won't get all the way through 1-2. Yeah. 1-1, just do the 1-1. I gave you all of the notes and all of the homework for this unit today, okay? But just 1-1 practice. All right, so let's get through this one. Hyundai Elantra uniformly accelerates from 12 meters per second to 20 meters per second in 3 seconds. What distance did it travel? So let's do step 1. Let's list what we know. What is this right here telling me? Initial velocity. So V naught is 12 meters per second. Okay, what does this tell me? V final. So V is 20 meters per second. What does this tell me? Time is 3 seconds. What distance did it travel? So what is it asking for there? Distance it traveled means we are looking for delta x, aren't we? How much did the distance change? Okay, so now we have to pick which equation we're going to use. What are we missing here? What do we not have here? We don't have we're looking for the distance, but we don't have we have velocities. Yeah, we don't have the acceleration, do we? So which one of these equations does not have acceleration?
Delta x.
Yeah. So that's the one we have to use, guys. Delta x equals v final plus v initial divided by 2 times the time, doesn't it? So what are we going to do with the two velocities? Atom. 12 plus 20 divided by 2 times what? 3 seconds. Gives me a change in position of what? So that's 32 divided by 2 is 16 times 3 is 48. 48, and make sure you use units, meters, right? Our units in physics are meters, kilograms, seconds, but in meters. All right. So we're going to pick up here next time. We'll pick up here and keep on going. But you do 1-1 practice, right? 1-1 practice before next time. All right, guys. Good job. You did a really good job today.